This video will begin our discussion of applying vectored value functions to three-space. Just like in Calc 1, we talk about the derivative and second derivative, where the first derivative means velocity, second derivative means acceleration, and then if I take the absolute value of velocity, I get speed, right? Speed is without direction, it's just the magnitude. All right, this actually applies in the exact same way for vector value functions. So if I have a position function r, I can find its velocity at any t, I can find its acceleration at any t, and I can find the speed. Okay, so take a look. We're going to do a few examples of this. Calculate the velocity and acceleration vectors at t equals 1 of that, then find the speed. Okay, so here's my function. I want to give you an idea of what each thing looks like. V is the direction, right, of which way the curve is going. That will stay on there. If I put it here, it should look something like that, right? The direction that the curve is moving. The acceleration vector explains the acceleration, how much it is accelerating. So calculate the velocity and acceleration of those vectors. So if I have r, I just have to find r prime. So r prime is equal to 2 cosine 2t. That's using the chain rule. And then I have 2 sine t, 2t. That's inverse. Derivative of cosine is negative sine, which takes care of the negative. Derivative of 2t is 2. And then the last thing, the half comes down. I'm going to do this off to the side real quick. T plus 1 to the 1/2. The half comes down. I got t plus 1 to the negative 1/2, and then times the derivative of the inside. So that's going to leave me with a, in the bottom, that negative is going to give me that square root of t plus 1. Oh, with a 2. 2 square roots of t plus 1 over 1. There we go. And they just want that value, or that vector. This is my velocity. So velocity, let me add a note in here. This, and you can fit it wherever you'd like. There we go. So r prime, or v, let's use v for velocity. And they want to know time is 1. So we get 2 cosine 2. I'm not even going to evaluate that because it's not pretty. 2 sine 2. And then 1 over the 2 squares of 2. That is my velocity at t equals 1. Right? They also want acceleration. All right, so acceleration though, let's find its actual function first. So a of t, remember, is the derivative of velocity or the double derivative of position. So derivative of my velocity, I got negative 4 sine 2t. Then I got 4 cosine 2t. And then that last one, okay, let's do 1/2 times t plus 1 to the negative 1/2. That's what that one is. So the negative 1/2 comes down to make a negative 1/4. T plus 1, lowered 1 again, is negative 3/2, and the derivative of the inside is 1. So we're going to get negative 1 over, and I'm just going to leave that as t plus 1 to the positive 3/2. Oh, and we forgot our 4. There we go. So 1 over that with a negative. I'm just going to connect these and make that negative. There we go. Okay, same thing. And they want that speed at 1. So we get acceleration. They want that acceleration. So this is sine of 2. I'm not even going to evaluate it because it's not pretty. Cosine of 2, and then plugging 1 into this business. Okay, we get negative 1 over 4 times 2 to the 3/2. I'm just going to leave it like that. 2 to the 3/2 is not clean. It's a square root of 8, which is going to make things complicated. I'm just going to leave it like that because that's what they asked. They also asked for the speed. So the speed, I don't want to use s because it's used for something else. What did they use up here? They didn't actually even give it a variable. So we'll say speed equals, it's the magnitude of velocity. Let's go ahead and throw 1 in because they didn't ask for a general one, which is also the magnitude of r prime of 1. Same thing. So the square root of 4 cosine 2, squared 2 plus 4 sine squared of 2 plus, and then we square that one, I get 1 over 8. 2 squared is 4, 2 comes out, I get an 8th. Cool. That we can actually take down further. 4, both of those, I can actually just factor out the 4. I'm going to show you here so I don't have to rewrite the whole thing. That's what we get if we factor out 4. This is equal to 1. So we get the square root of 4 plus 1/8. 8 is 32 over, 4 is 32 over 8, so we get 33 over 8 radical. So that's the speed. I don't think they gave us units in this, so we'll just leave it alone. So that's how we find velocity, acceleration, and speed. It's not any different than Calc 1. Let's do one more example like this. They want us to find r of t if a of t is that, v of 0 is that, and r of 0 is that. All right, so we got to start working backwards. They gave us initial conditions, and they gave me a of t, so we just have to work through those. All right, so let's start. A of t equals that. So if I want to find v of t, the velocity, then that is the integral of a to the t dt. So that's the integral of 2I plus 12tj dt. We can do that. I'm not going to write these out separately because that one's pretty straightforward. We get 2ti plus, go up by 1, divide by the new one, I get 6t squared j. You can also check that by taking the derivative. This is each one, oh, we should have added this in, forgive me. We should put plus c1 and then plus c2. Come on, I should have just erased. Plus c2. Right now, so we have velocity of t is equal to 2t plus c1 and 6t squared plus c2. We can actually plug in 0 and use those initial values to help us out. I got c1, c2, and we set now equal to IV, initial value, and that is here. Oh, no, it's here because it's velocity. So this is going to be 7, 0, 0. Just 2 components, actually, not 3. Oh, we made a mistake. So this actually, be very careful, this has a 0k. The reason I didn't involve k is because none of them, but here tells me there is a k. So what we add to this is c3. The derivative of a 0 is that. So we get k here. I'm just going to add all these in. It's not too much. C3. Set to initial value. So we get 7i, 0j, 0k. So the only thing we really grab out of this is c1 is 7. The other two are 0. So velocity is equal to 2t plus 7, 6t squared, and 0. All right, so now to find our position function, we take the integral, can't get it out, integral of velocity, and go backwards. All right, so get the integral of 2t plus 7, I, plus 6t squared, j, sorry my phone's ringing. I'm not sure who that is. I'm just going to ignore. Sorry, that thing never rings, so that actually kind of caught me off guard. I got 6t squared, j, and then plus the last one is going to be 0k. All right, our integral, I'm going to just do all of them pretty straightforward here. I get t squared plus 7t plus c1 star I plus, okay, that's going to go up by 1, divide by the new one, I got 2t cubed plus c2 star j, and then plus c3 star k. All right, so there is my position function. I'm now going to use my initial value, plug those in. Oh, I actually left my integral there, but we did the integration. That is silly of me. Take that away. There we go. I think the phone threw me off. All right, that's what we got there. So now we're going to plug in 0 to all of that, and we get C1 star, C2 star, and then we get C3 star. All right, we set it equal, set to IV, initial value. I got to scroll back up to check that out. That's here, 209. 209. So C1 star is equal to 2, and C3 star is equal to 9. The other one's equal to 0. I guess we could write that 2 star is equal to 0. So now I can actually write my answer. R of t is equal to t squared plus 7t plus 2 I plus 2t cubed plus 0. I don't need that. J. And then the last one is just 9k. And there is our position function. You could check this. You plug zeros in. You could take the derivatives and get to the acceleration. You just need to make sure that it works out that way. These are a bit of a pain because of the length, but they're just integration and then algebra to find our constants.